Hello everyone. Welcome to Instrumentation Insights Hub IIH, your one-stop destination for in-depth knowledge on instrumentation and automation in the oil and gas industry. I am your host, a passionate professional YouTuber and enthusiastic automation engineer having 12 years of hands-on experience in this field. As an instrumentation and automation engineer, I have worked on complex projects, tackled real-time challenges, and stayed updated on the evolving standards and regulations that drive our industry. Over the year, I noticed a gap in the way critical concepts are explained online. While there are numerous channels offering bits and pieces of information, I found it little frustrating that no single source provide comprehensive start to finish details on topics related to oil and gas. That's why I created this channel to address this gap and deliver content that's both informative and complete. My goal is to give you all the insights you need about oil and gas standards, regulation and guidelines, application, principles in one single video. Here, you won't just learn the basics, you will walk away with a detailed understanding of every concept we cover. So you never have to jump between multiple sources to find your answers. Whether you are a seasoned engineer, a student, or someone new to this industry, my channel is designed to make technical knowledge accessible and actionable. So buckle up and get ready to explore all the oil and gas, automation and instrumentation related topics. And today's topic is hazardous area classification. So let's explore today's topic in depth. Coming to first slide, I will start with what is hazardous area and why classify an area as hazardous is important. A hazardous area, also known as potentially explosive atmosphere, is defined as an environment that consists of any concentration of flammable gas, vapors, mist, or combustible. So, in oil and gas, flammable gas and vapor is important. For mining and other industries, mist and combustible dust is also there. Combustible dust also in some plant you may find in the solid handling oil and gas plant. So why classify an area as a hazardous? Because to eliminate the potential for an explosion, promote the safety of personnel, and prevent property damage. So this is the reason to classify an area as hazardous. So this is the main reason for creating this presentation, that what all the regulations and guidelines available worldwide which regulates the industry to classify an area as hazardous. So if you are working in USA, if you are working in European countries, you are one is globally accepted regulatory body is there in India, in Canada, and Australia and New Zealand. So you can see that regulation and guidelines applicable in USA is OSHA and NEC, and in for European Union, ATEX body is there, and the widely accepted regulatory body is ATEX, and all other standards are driven by ATEX only, somewhat taken from the ATEX and created in related to their continent. Like globally, one IEC EX certification scheme is derived, that is also derived from ATEX. India has PESO and IS, Petroleum and Explosive Safety Organization. Canada has CEC, Canadian Electrical Code, like NEC, National Electric Code, which is applicable in USA, Canada, CEC. Australia and New Zealand has ASN NZS 60079. So area classification according to their guidelines is different for across all the continents. Like in USA, class division is more in practice, and in European, global, India, we follow somewhat ATEX certification. So only zone works. All right. So in Canada and Australia, class division is more in practice. So, what are the equipment certification required under various continent? You can see here equipment certification, NEC compliance, CE marks with EX. So, I will show you one example of where CE and EX both certificate marking is there. So, I will explain that also. And IEC EX scheme is also derived from the ATEX, which is accepted widely and globally. So this is the international standards, and from this ATEX certification, we have derived IS 2148 for the flame-proof equipment. This is one of the example IS for the flame-proof standard, IS Indian standard, and likewise. All right. So key standards under various continent: NFPA 497, 499, 497 is for dust, 499 for 497 is for gases, and 499 for dust. Likewise, EN 60079, IEC 60079, like Indian Standard 5572 and IS 2148. So IS 5572 is for classification, and IS 2148 for flame proof equipment, CSA, and likewise. All right, and this is focus on training. I mean, if someone is capable of, or some organization is capable of classifying any instruments to be used in hazardous area, so what's that should be competent personnel as per OSHA guidelines, mandatory worker safety training required for IC compliance, and these things are there, right? So moving further, so in previous slide we have seen that regulations and guidelines. So based on those regulation and guidelines, what are the standards? What standards are prepared? So NFPA, National Fire Protection Act 70. This is applicable in USA. ATEX directive. This is very widely used. And based on ATEX directive, we have created international widely accepted IEC 60079. So ATEX directives, equipment directive 2014/34/EU, and worker safety directive is this. Equipment directive is 2014/34/EU, and worker safety directive is 1999 92 slash EC, right? So based on, derived from ATEX IEC 60079, international standard for electrical non-electrical equipment in explosive atmosphere is there. API, industry specific guidelines for hazardous area in oil and gas, NFPA 497, we discussed in previous slide also, flammable gas and vapors, combustible gas. And IS 5572, this is Indian standard for hazardous area explosion proof, right? And ISO, this is also international non-electrical equipment for this. So these are some laws and standards, right? So in the previous regulation and guidelines we discussed, and based on those regulation, what are the standards we see across the world? So these are the standards followed across the world. Now, as we are working in India, so regulation and guidelines in India which are being followed. So regulatory authority is PESO, Petroleum Explosive Safety Organization. So all the equipments which are used in hazardous area should be petroleum PESO certified, right? Key regulation. Regulation based on PESO guidelines. What are the regulations prepared? Explosive Act 1884 and Explosive Rules 2008, Petroleum Act 1934, Petroleum Rules 2002 for handling flammable substances, Factory Act 1948 ensure workplace safety for hazardous area. So this is personal related and this is equipment related, right? And these are the regulations, and these are the guidelines, or I would say these are the laws which we have to follow, and the standards which are based on these regulations and law are IS 5572 hazardous area classification for process plant, IS 2148 flame proof electrical equipment, and IS, I would say, or IEC 60079. It is completely taken from the IEC 60079 and IS. We prepared IS 60079 exactly somewhat same. I have read this IEC 60079 in detail also. So I can say that it is exactly same as IEC 60079. So explosive atmosphere standards aligned with IEC. All right. IS 1646 Code of Practice of Electrical Installation in Hazardous Location, and many more. Right. Equipment certification. Equipment must be certified by authorized body like BIS, Bureau of Indian Standards, or PESO. So PESO is somewhat I see is most widely used, and in the last international practice, let's go further. Area classification based on IS 5, which is aligned with IEC 60079. I already told. So zone wise classification is there, which is derived from the IEC itself, and for which is initially derived from ATEX, right? Yeah, European Union, right? So marking requirement. Equipment must display the certification marks. Example EXD, that is explosion proof. 2BT4 PESO approval number, include temperature and this. So key guidelines which we follow is OISD standards, oil industry safety directorate, you know, for petroleum and oil and gas industries, and static and mobile pressure vessel rules 20 for pressure vessel. This is particularly related with pressure vessel. International practice often aligned with ATEX. This is the main. If your equipment is not authorized or not having approval of PESO, we can also use ATEX certified equipment in India. So this is widely used. ICEX and ATEX is Europe. So this is and we have PESO certificate. We have IS standards which are also derived from these two standards only. So this certification also works in India. Going to next slide. These are the some examples like key Indian standards: IS 5572, IS 2142, IS 60079, and IS 1646, IS 13346. So you can read the title of these Indian standards, which are derived from the ATEX and IEC, right? All right. So uh, already discussed that approval agencies in India. One is the PESO, other is BIS, other is Central Institute of Mining and Fuel Research. So for oil and gas industry, I would say the PESO and BIS is the main approval agencies, and the key standards starts from IS, Indian Standard, right? So 2148, 5572, you can have some detail over the internet also. And for the mining industry, Central Institute of Mining and Fuel Research, CIMFR, Directorate General of Mine Safety, DGMS, and right. International certification recognized in India, in the last line here, you can see international certification recognized in India, which are IECEX and ATEX. So in the nutshell, till this slide, we can say that ATEX, IECEX, or IS, Indian standards, all are same, because we have taken all the sections in IS from the ATEX, right? So this is most important thing, that IC 60079 series, ATEX directive, and IS all are same. So equipment uh, used here in India should be ATEX or IEC approved, right? So this is the typical marking of hazardous area as per ATEX, I would say, and also so you can see that this is the CE, European, the notified body, European Community, manufactured according application to EC directives. This is CE. Many times you have seen that this CE logo. So this is for European Community. And after that, you notified number, CE notified number, petroleum surveillance. This is that number. And this marking EX for equipment used in explosive atmosphere. This is the standard which are being followed for having a ATEX or IEC certification, right? This is the equipment group. One is for mining and two is for different mines, right? So this is two, right? And one is for M1 is for very high protection, and M2 is high protection, and G is for gas, vapor, mist, and D is for dust, right? For non-mines, 1, 2, 3, and for associated apparatus, right? IEC standard marking, this is the IEC standard marking EEX for a specific type of protection according to the applicable standard. Type of protection, IA, type of protection, this is related with something, what type of marking should be there in the instrument which is used in hazardous area, right? 2C is the gas group, T4 is the temperature class. We will see in detail also in further slide. G is the EPL, equipment protection level. Coming to the IEC standard, IEC EX is further give some numbers and marking. So ICEX, if you are having a IC marking, so ICEX scheme. After that, this is the attacks number, and this is the attacks marking, and this is the IEC marking. ICES BBS 14 year of issuing attacks. This is the attacks directive being followed, and 0019 certification number progressive, and X is the particular condition of use or component likewise, right? So attacks directive 94/9 or EC is a legal marking, IC is a technical marking. So this is the nutshell. In nutshell, we can say that attacks directive 94/9 that EC is a legal marking. This is required that this equipment can be used in India, in European country, or in other countries. And this is a technical marking of that equipment that yes, this can be used with this much protection technique, this much temperature group, and this much gas group, right? Now we will see in detail what are the type of protection, gas group, temperature class, EPL, right? So coming to the classification nomenclature, first of all, this is preferred in USA class zone system and class division system. So we will discuss class zone system nomenclature. So class division is preferred in USA and class zone system is preferred in European countries and India. So class 1 is permitted for gas and vapor, class 0 is ignitable concentration of gases, vapors are present continuously for a long period of time. Zone 1 is ignitional concentration of gases or are likely to exist under normal operating condition, and ignitional concentration of gases or are not likely to present. So this is a continuous presence of ignitional gases and vapors, and likewise. Coming to conformity to US requirement A, this is not applicable for India, and EX is the explosion protection used in that equipment to be used in hazardous area. IA is a method of protection, we will see later. 2C is the gas group, T4 is the temperature class, and GA is the EPL. We will see in detail. So now onwards we will discuss only class zone nomenclature, because in India we follow the class zone nomenclature. So classification nomenclature 2G CEEX, that is clear. C is the we will again 2 2 is for other industry, that means no mining, oil and gas 2, and 2G is continuously for long period of time, occasionally, or this, right? Equipment categorized by and 2 occasionally, I mean expectancy of the occurrence of an explosive atmosphere occasionally, right? And level of protection high with one fault, that is 2, and G is for gas. So zone 1 is decided. So if the area is zone 1, that means 2, this all this combining these three letters, we can define the zone. So zone 1, if someone is saying zone 1, that means equipment category should be 2, right? And gas is there, so that is why zone 1 is coming. Dust is there, so zone 21 is there. So let's say gas is there, so zone 1. So one fault and very high level of protection is required right? So that will make 2G, right? Going to next slide. Yes, 2C. 2C means if 2A is there, then mines, for mines group class is 1. For explosive 1A, 2B, 2B, 2A, 2B and 2C classification is there, in which you can see that ammonia, methane, and this is there, and city gas, acrylic nitrile, right? And in 2C you can see very dangerous hydrogen, acetylene and carbon disulfide. This is very important because 2C covers all explosive gases which are very combustible and which can catch fire in no time, right? So explosive dust is there, then third C, third A, third B and third C is there. The list is only a selection of possible flammable medium and is not complete, right? So 2C, that means 2C hydrogen acetylene is available in the hazardous area. Coming to the T4 temperature group, you can see that yes, this is the maximum surface temperature. So T1, T2 and further T2A, T2B, T2C, T2D, T2, right? So this is further classified at T class. You can see T3 further, and T6 is 85, right? So higher the temperature class group number, lower is the maximum surface temperature of that equipment. Coming to the EPL, this is quite interesting. Equipment protection level is defined by the international standard IEC-EN 60079. The assigned EPL of equipment indicates the risk level or likelihood that the equipment can become a source of ignition. So in zone 1, GA, GB and GC. So GC is there, so likelihood of so GA, a very high protection. The equipment remains safe in normal operation given in a rare fault situation, two fault at once. GB, DB and MB for dust and other things. So GD, DB and MB high protection. The equipment remains safe in operation, in normal operation also when one fault occurs. Single fault, if there is a single fault, then the equipment remains safe. And the GC enhanced protection. The equipment remains safe in normal operation and may have extra protection to minimize the ignition risk in fault situation. Fault may cause equipment to shut down, right? So in a very hazardous area like hydrogen or acetylene, GC is used, right? So this is equipment protection layer. Coming to you must have heard that IP67, your phone is coming with IP61 or something. So this is the protection degree. Dust tight 6, and first numeric protection against the solid, and the protection against the water. So this is the equipment protection level. EPL is same as your IP number. Protection against solid, dust light 6, and in water 1, vertical dripping, angle dripping, spraying, splashing, jetting, powerful jetting, temporary immersion, continuous immersion, right? So this is the T4 and this, all right. So coming to the EXD, this is very important, equipment category and protection type. So this is the table you can refer, and zone wise protection symbol. If EXD protection is there, then that can be used in zone 1 and zone 2, flame proof inclusion. And increased safety is there, so that can also be used in zone 1 and zone 2. IA, IB and IC, intrinsically safe. So if IA is there, that can be used in zone 0, zone 1, zone 2, and this is IB, zone 1, zone 2, and IC, that is only applicable in zone 2, right? MA, molding. These are the techniques, protection symbols. So these are the techniques by which we can protect the instrument or equipment particularly to and these are the techniques, right? So that can be used in such areas. If likewise, if I see protection technique is being used in that equipment, then that can be used in zone 2. So oil immersion, powder filling, Q, and Na, Nc, Nr, Nl, non-sparkling enclosed brake resisted limited energy, and pressurized enclosure is Px, Py, and Pz. So, and these are the some standard, the intrinsically safe if IAX be EPL, if GA and MB, so IC standards 60079-11 can be used. Likewise, right? So you can refer this chart also if pressurization is there, right? So we can follow 60079-2 IC standard, and these are the US based standards. So for your knowledge purpose, you can refer it. So I have covered all the aspects related to hazardous area classification, and in the next video, I will be coming with the protection type, equipment protection layer, and what are the protection technique used in equipment to used in hazardous area. So thank you for watching, and don't forget to subscribe, like, and share. And this will help me for promoting my channel also. So this is one of the many in the topics I covered today in on my channel. My goal is to save your time by providing you all the relevant details in a single video, so you don't have to go anywhere else. If you found this video valuable, so don't forget to like, share, and subscribe to IIH. Hit the bell icon to stay updated on the latest oil and gas related topics related to instrumentation and automation. Thank you.